So I think everyone in the Pantera family has been really excited about this presentation on security for crypto companies with Trilobits. For those who aren't familiar with Trilobits, I got familiar with the team back when I was still in the JP Morgan blockchain team. They've always been highly recommended and have done great work both for our portfolio companies and companies across the cryptocurrency industry and even outside. They're I think one of the best security research firms out there. They bring a real world attacker mentality to the work that they do, and they have clientele ranging from Facebook to DARPA. I'll let Dan take over the presentation from here and go through a couple of case studies and high-level intro to how to think about security practices. Thanks, Dan.
Cool, great, thanks. Yeah, and apologies for not for having to reschedule the last meeting at the last minute. I was sick, and who knows with what these days. So thanks for making the time. So Stefan and I are here to talk about traditional InfoSec meets blockchain. We figured the best way to go about this was to just review empirically the kind of things that we've been finding for clients of ours. So we pulled out 4 case studies from real projects that we've done. And for each of those case studies, described a couple things about each that I think the audience that you all would like to know. So as Franklin introduced us, Trilobits is a software security research and development firm. We have a lot of different things that we do. We're not doing just blockchain security. We have a research team that works really extensively with, throw my phone away, that works really extensively with DARPA. And yeah, the background here, I think everybody's got like a really funny, neat, unique remote working kind of setup now. This is mine. I'm in the basement. I have a sun to remind me what it looks like outside and this bright yellow rug just to brighten up the place. Yeah, anyway. So we do a lot of stuff. So we have a research team that makes foundational discoveries in computer science, typically with DARPA and also with the DoD at large. We incorporate a lot of that knowledge and a lot of those tools into the other offerings that we have. So we have a security engineering team that builds software for clients of ours. Usually that ends up being things like security tools. Sometimes it ends up being high assurance software. So cryptographic software, software that lives in embedded systems that drive physical objects, that sort of stuff. And then we also do security assessments. And those security assessments, the kind of like key defining type of security assessment Trilobits works on are high assurance assessments. So things where there is a real risk of failure if there are bugs in the code. So that encompasses blockchain security, obviously, but it also encompasses security tools themselves. We get a lot of work from security companies because it turns out when you deploy security tools, usually you grant them wide-ranging access to your network and keys. But we also look at cryptography. We look at all kinds of like cyber physical systems, cars, planes, that sort of thing, as well as a bunch of other like related areas. So we like doing all that stuff, and with that stuff comes a lot of traditional InfoSec. Like as much as I want to get away from like, how do I secure my Kubernetes cluster? How do I make a secure web application? Or how do I manage keys? Like that's still part of it. We want to talk about all that stuff with you. So like I mentioned, we've got 4 case studies. For each case study, we wanted to walk through the problems they came to us with. So what were the goals of the engagement? What were their concerns on day one? We talked through our assessment approach. So what we did to satisfy those goals, and also implicitly what you could do. And then what we discovered. So empirically, what are the kinds of issues that we found? A few examples, just so that you can think through this for your own networks and tools and data. And then lessons learned. And there are lessons learned both for us as a security company and lessons learned for our clients. And then we conclude on some references and advice for all of you that we think is important. I'm saying a lot, but Stefan, am I getting this all right?
Yeah, no, that's spot on, Dan. I mean, it's I think a very interesting one, and we'll get into it as we get into like some of the case studies that we picked up. But I think the thing that's very interesting to me as I've grown working with blockchain companies and organizations trying to move into blockchain and people trying to really understand things, I think the sorts of things that I see are lots of organizations are really struggling or really trying to grapple with, like, where does their maturity in security fit for both sides of the house? Where do our traditional, like, oracular components, our off-chain components, what is our maturity there? And what is our maturity for our on-chain components? And it's been really interesting, and we'll get into some of these case studies to see where those things can fail and where their interactions can fail. Because I think, especially with security firms and especially as folks are getting into blockchain, it's sometimes easy to understand one side or the other, but then actually understanding the interaction between the two is also non-trivial. And there's some interesting failure modes or interesting edge cases that we've seen with some of these clients as well.
Yeah, we worked pretty hard to find those kind of overlaps and really dig into them in this presentation. So we'll definitely get to that. Awesome, thanks. All right, let's go through the first case study. I think Stefan's going to lead this more than I am, but we wanted to talk about compounds. Yep. Oh, go on.
No, I was going to say, everyone's heard of Compound, right? Like, this is a fairly large organization, fairly mature, and there's a lot of interesting things that we've seen with Compound itself, and they've very quickly grown to be, I don't want to say a standard, but they've very quickly grown to be a very large player in the space that they're in. So any sort of issues that we've seen or anything we've discussed with them, has gone from, oh, we're thinking about these sorts of things and we're trying to grow in this marketplace. That's where we met Compound, to now Compound is like the 800-pound gorilla in the room for a lot of the semi-decentralized finance sorts of applications. So it's been interesting for us to interact with them as well.
Great. So what did they come to us with?
So when they first came to us, and we've had obviously an evolving relationship with Compound, but when they first came to us, they were just really looking for the sorts of security correctness issues with their code. Does our code work the way we expect it to? Does our off-chain components interact with the ecosystem at large in the ways that we actually understand and expect them to? And then over time, through discussion, we've actually kind of enlarged our relationship with Compound. So we started with just a very simple sort of like, hey, can you do a security review of our Solidity code? Can you look through some things? And then we've gone through to realize, like, oh, well, this Solidity code actually may have these sorts of regulatory impacts if X, Y, and Z happens. So we've really started to grow not just the areas that we're helping them with and their maturity, but really the problems that they're looking at and the sorts of risks that they themselves are facing as they've added capital and assets to their management portfolio. So it's a really interesting space for us. I don't know, Dan, did you were there when Compound was first coming on as well too, so.
Yeah, no, I think you got it. The question was pretty open-ended, which I was happy to have. Sometimes people come to us with, oh, we just want you to look at these 10 lines of code or whatever, this like, set of files. But we were given pretty wide range to look at problems across the business and to think through issues and risks that they didn't expect they'd have to worry about. So I think where it started with security and correctness, we ended up realizing mutually through the engagement that, hey, there's more stuff here that we should be concerned about, which I think is exactly the kind of thought process we wanted to convey through this presentation, is that, hey, there's more than just on-chain stuff that you need to worry about. What did we do, right? So all these projects, clients of ours, they come to us and they've got a different problem that they want to solve. And we have a lot of tools in our tool belt and different approaches that we can take to try to remediate and help people understand those issues. So for this, the approach was a pretty well-known, tried and true, straightforward kind of engagement that we've done many times before. And Stefan can walk through about what that approach looks like when it's done typically.
Yeah, and the interesting thing with Compound was that they came to us and they're like, we actually have these off-chain components. We have some tests in Truffle. We have some JavaScript that helps load things on chain, and we really want to understand our entire risk profile here across our enterprise or across our organization. So when Jeff and I were first discussing the project, we were looking at some solidity, and I started to ask some questions about where things are loaded, and we started to open up larger and larger areas here. And we went through the normal sort of, like, if you see in the top right-hand corner, this is from NIST 800-115. It's basically the planning and reporting loop that you go through when you're doing technical testing. So we initially planned out some components, some areas of the application we wanted to look through. We mapped the application itself, went through, discovered all of the edges, discovered areas where, oh, hey, this portion is loading a key from an environment variable, those sorts of things. And then we started to actually attack. And some of these attacks are not always going to be technical attacks, right? So for example, if there's a key loaded into Kubernetes, and we're talking about the sorts of procedural controls that Compound itself or other organizations may have, some of these attacks are just us talking through and saying, what happens if someone walks out your door with that key? Do you have anything in place that you can rotate that key, that you can, you can disavow using that key, those sorts of things. So it's a very interesting process, very fluid, but it basically follows this sort of flow diagram of mapping, attacking, and then reporting out the things that you have attacked successfully, and adding any new assets that you've discovered throughout that process to the map itself, and continuing until you've either exhausted time or you feel like you've gotten really good coverage on all the components within the system. And then we also did an architecture review. And part of this was just sitting down with the Compound folks, looking at their architecture and staring really intently at it, and talking through about some of the security controls that they themselves have implemented, or some of the controls that they actually inherited from the environment that they gained. So Kubernetes has a set of assumptions, and we at Trail of Bits have actually done a source code and an architectural review of Kubernetes itself. So Kubernetes has certain assumptions, certain security controls. The cloud environment has certain assumptions and security controls. And so talking through with Compound, understanding how they're deploying things, understanding how developers internally to Compound are accessing things, and really walking through their entire suite of procedures, their entire suite of code bases, we've actually discovered things and edge cases that were fairly interesting failure modes for the design choices that they had.
Great. Yeah, this is pretty straightforward for us. And we'll start to dive into, like, as these case studies progress, we'll talk through more of the, like, on the ground kind of techniques that we use, but this is just a very high level intro. So we found some things. Stefan, what did we find at Compound?
We found some very interesting, like, contract level bugs, right? Like, as we're talking through things, we realized, yes, there should be maybe some like the ability to pause the money market. We found some areas where they could maybe clarify some code. When I remember looking through the access control for the actual contracts themselves. Initially, they didn't use a modifier. A lot of that code was in situ, in functions. And so we made recommendations on how to refactor things, how to clean things up, etc. So their solidity was mostly that level of issue. Where it became more interesting was looking at the off-chain components, right? Because those are the things that actually drive the on-chain components, or load data, or bring things into the system so that users on the blockchain can actually interact with them. And there was nothing earth-shattering from maybe Dan and my perspective, right? This is all things that we've seen before. Keys are maybe exposed. You maybe need some bastion host cleanup or those sorts of things. But it was very interesting to talk through and discuss the failure modes for things. Looking through some of the libraries that were used, even for something as simple as fetching prices, there were several exchanges that did not actually list their prices over a secure channel. They didn't use TLS for their HTTP connection. So Is the risk there extremely high? No, of course not. Several factors would have to fail in order for an attacker to actually affect that sort of thing. But if you're unaware that this is possible, or if you're unaware that there could be some error cases or some attack avenue there, it can open you up to risk that you never expected when you're just doing something that's on chain, or when you're doing something that should be relatively simple and straightforward.
Yeah, and this document that we produced for them is not public. It might be soon, maybe, who knows? But I really dug into the depths of our archives here and pulled out 2 examples that I think summarize some of the issues that we found with them, where hygiene around network level access controls, as well as the way that they manage keys for the Oracle components that they've got, and some of the recommendations that, again, aren't earth-shattering to us, but was new information for them at the time, and have long since been able to grow and work past. I mean, I think that report's from like 2018.
Yeah. Appendix F was really going through it. It actually became a document unto itself here at Trail of Bits, but it was literally going through and saying, hey, this key, you can remove it from the file system, or you can remove it from Kubernetes itself, and you can put it into GCKMS, or you can move it into this area, or watch out for it being exposed over here. So just those sorts of like procedural things and strengthening and hardening across the enterprise was a very useful task for them across it. Yeah, and
so if we had to boil down the lessons learned, right? So go on, Stefan.
Oh, I'm sorry. If we had to boil them down, I think it was an eye opener for us, because this was our real first interaction with Kubernetes and blockchain. I came from a company prior to Trail of Bits that had done some Kubernetes work, so that sort of thing was not especially new to me. But what was interesting is all of the new ways that Kubernetes and blockchain may interact. It was our first real review of something that used Kubernetes for hosting, used it for oracles and that sort of thing, and then producing sort of like secure guidance around how you handle these sorts of things, how you handle deployments, off-chain components, keys, all that good stuff that we all know actually lives, but many organizations don't necessarily have plans in place for when they're deploying things to the chain, or when they're working with them. They don't necessarily always consider what to do with all the off-chain stuff. And so Compound became our first organization that we really started to write up this guidance and come up with some standards that we provide to all of our customers therein.
Yep. Yeah, and one thing to note here is that the follow through from the Trail of Bits side is always like, I try to push this kind of knowledge and this kind of process once we get on it as far as we possibly can. So about a year later, this culminated with a security review that we did for the Linux Foundation of Kubernetes itself. I'll pop up in the. So we keep track of all of our publications on this GitHub repository, and you can see we've got a really, really extensive security review of Kubernetes. So these things kind of grow on our side too. Like it's never a single thing. Whatever. You can go look at that later if you feel like.
Yeah, we had there's 3 reports, as Dan mentioned there. Kubernetes, a security review for the code level. There's a security ergonomics review. So we look through and try to determine how difficult is it to actually securely configure Kubernetes itself. And then
call it security usability. I think more people might understand that. But yeah.
Security usability.
How many foot guns are present in this code base?
Right.
And the answer was many.
And also a threat model for Kubernetes itself. So I actually sat down with some of the designers who work at Red Hat, who work at Google, and not only was I reviewing code with a team here, but I also sat down with the designers themselves and said, hey, tell me what you were thinking when you designed this thing. So it was a fairly fascinating project, and lots of interesting reporting came out of that one. So like Dan said, we started with just one client who had some Kubernetes stuff, and then we really pushed through to the end and actually went to the source of Kubernetes itself.
Yeah, we realized that was a systemic problem. So we did our best to get it at the source. Okay, so that's Compound. I wanted to throw one wild card in this presentation. So I did say that this is going to be traditional InfoSec meets blockchain security, but I don't think that on-chain security is a solved problem either. And I want to talk through one case study where I think we pushed the limits on what was possible and really reformed somebody that had approached this in a more ad hoc manner, and then gave them a lot more visibility and control and understanding of what they were trying to do. So OX, again, like I don't think I really need to introduce OX or like who they are, but when we first talked to them, they were in a state of being surprised. That's how I would describe it. That a wild Samsung appears and drops Ode on your on-chain components, and it's usually something that's massively severe that he's already got an exploit for, and it's something that you didn't expect because you probably already hired a couple of security firms, and a couple of security firms told you that, hey, the code is safe, or rather, maybe that's the way you interpreted it. So the state of being, I think, for many blockchain companies is that they've completed a bunch of security reviews, and all of them have been very piecemeal. They have somebody stick their hand into the code base and rip out a bunch of bugs, and they say, okay, here's all the stuff that's wrong. You should go fix these. But there's never really a holistic review that's done that gives you perspective and understanding across the whole code base about the kinds of risks that you've inherited by the way you developed your code. So a lot of these like architectural focused or threat modeling kind of focused or simply like holistic, I can't really define it better, reviews just aren't getting done. People are doing these point in time assessments of let's see how many bugs I can find in the shortest time period possible. So when we talked to them, some of their goals were, well, we need to remediate this new hotspot, right? Samsung found this issue that was related to low-level solidity. So obviously we need to look into that. We need to adopt much stronger, best practices, because clearly this like manual review-driven system is missing things. How do we use automated tools and program analysis tools and other kinds of advanced techniques to get more value out of the security investments that we make? They also wanted to hop on the buzzword train, right? You want to do formal verification. Everybody wants to do formal verification. Nobody knows how to get started. So how do you get started on that? And then lastly was, if we were surprised once, are we going to be surprised again? Is there another hotspot in the code that we don't know about right now that, you know, Sam's going to come back in 3 months and bop us on the head all over again? So, you know, that's a screenshot from Sam's blog. And then that's the comment that the OX team initially had about, well, how come we didn't find this before? And I think it's really endemic of the process of, you know, hey, we're just going to get, you know, multiple security reviews from multiple different companies, and everybody's going to look at it from every different angle, and it's all just ad hoc. Nobody approaches this in a deliberate manner that gives them holistic understanding. So we needed to do that for them. I cover all that, Stefan?
Yeah, I think that's exactly right. I mean, we're really trying to expand. This is something Dan and I talk about very frequently. Moving away from the sort of like reaching into the code base, pulling out a bunch of bugs, and really trying to move towards a very specific coverage-based, property-based security model, and really relay things in a way that not only can you understand what we found, but you can also understand what we were doing. And I think many security firms struggle with this, and we really have the time and the space to start to experiment with how we relay these sorts of things. And OX was a great way of like experimenting with this with a live client with a real need to get this right, because they had been, as Dan said, like surprised by this sort of thing that Samsung had brought up. So super fascinating.
Yep. Cool. So what do we do? Right. So obviously, like, we could have started just by the same way that everybody else did. Like, okay, well, it's trail of bits. So that means we're smarter and better and have better tools. We're going to dig deeper and we're going to like find more bugs in less time, and they're all going to be more severe. But we resisted that. The approach here wasn't going to, like, the client wasn't going to benefit from us just having a crack at their code base too, because they'd still be left with the lack of understanding needed to identify future hotspots and plan a security development lifecycle or other security investments 6, 9, 12 months from now. So we started with an architecture risk assessment. And the way that we typically do these is as a control-focused review. So we picked out 7 controls that we thought were really important for on-chain blockchain systems. access controls, the quality of the state machine, arithmetics, external interactions, assembly use, contract upgradability, and standards conformance. And then for each of those, we rated them through all the components that they had as either strong to weak or missing. So that gave us a sense of like, where are the weaknesses in this code base and what are the worst problems that we need to solve? Because then we can target our efforts directly at those components. So how do we actually approach remediating those components when we find them? Like if we looked at the proxy system they created and we find that some state machine usage inside that component has weak controls, what do we do to actually remediate it? Well, we're not just going to go hand review the code, because one person's understanding of those systems is going to be less or different or greater or whatever than somebody else's understanding of those systems. That's why all these blockchain companies keep trying to hire like every security expert on the planet to look at the code base from a different direction and why it doesn't work. We wanted to provide provable assurances out the other end, and really define like what assurances they were looking to get. Because I think OX had really accumulated a large amount of complexity and a large amount of code over a long time period. And they hadn't actually written down like, what is this code supposed to do? So we followed a process that we define in this training material that we put online called Building Secure Contracts, where, we have some development guidelines. We've documented kind of the lessons learned of how to develop on-chain components that we think are useful to follow. So empirically, like what works and what hasn't for our clients. But really what it walks you through is, how do I define a security property for my system? What is a security property for my system? And then how do I use program analysis tools to prove that I either meet that security property or do not? So we targeted our investments to the areas where their controls were the weakest and where we thought the impact was the highest. And what did we do? Or well, let me pause here. Stefan, is there, I'll just check in.
No, that's spot on, Dan. Keep going.
So what does the output look like? So on the first, I should make these into numbers. So first step, you've got this asset proxy contracts. These are just screenshots from the various reports that we produced for them. Here's an example of what that architecture risk assessment produced. We've got a single component in the system, and we've got a list of controls as well as our rating of like how well are those controls implemented in that system. And you can see that state machine transitions for the asset proxy contracts require further investigation. Like we don't know if they're strong or weak, but they're kind of like giving us a little bit of a bad feeling. And we are going to target this in the upcoming security review. And the way that we're going to target it is we're going to write a whole bunch of we're going to define a whole bunch of security properties for that specific thing. And then we're going to use advanced program analysis tools like, say, Echidna, which is our property tester fuzzer, to increase the security maturity of that system. In addition to that, we also did the typical, like, stick your hand into the code base, pull out a bunch of bugs, and found 23 issues, some of which were also high severity, and I commented there. But I think the overwhelming benefit of having gone through this is now we know we have like a treasure map for, if I was Samsung, here's the next place that I would look, or if I'm OX, here's the next place I'd invest in. And then we have 135 defined security policies now, or security properties now, and we've got the code to test all of them. So we know that at least for those 135 things, that those 135 things aren't going to be your problem. You can go to somewhere else in the code base. You can look at the next hotspot that we didn't get to, or the thing that was marked as weak, but not necessarily missing or further investigation required. So this document is available in the Trail of Bits publications repo, just like the other ones. And you can kind of see what it looks like. Let's see. So here, yeah, let's see if I could find the asset proxy. Exchange libraries.
And while Dan is looking for that, one of the benefits too of doing like architecture reviews, of doing these sorts of property extractions, is that when you go through, and you can do these techniques yourself, there's nothing that stops you from doing this. You can have us do them, you can do them yourselves. But when you do these sorts of like, okay, we're going to pause, step back, and we're going to do an architecture review, and we're going to look through the properties, you're actually starting to try to gain understanding of what the system is currently doing and what you think the system is currently doing, and making sure that they map. Now, obviously you can do that mentally. You can go through and think really hard about things or reach into a code base and find a bunch of bugs, like Dan said. But if you start to extract these things, you can also make sure that they continue to hold. So if you have some property that you've extracted, you have some invariants that you know should hold for the system always. Whenever you run a new new tests, or whenever you add new code, you can make sure that they continue to hold. Your assumptions about the system continue to exist.
Right. Now, there's a couple of really important points to pick out about this process for doing a security review, or about making a security investment in the code, right? Because this isn't a point in time review. This lasts forever, like Stefan just said. Once you've got the properties defined, like, this property isn't going to change unless you architecturally completely refactor the whole system. But that property is never going to change. What might change is the approach you use to prove it. So today we're using Echidna to prove it. That's a fuzzer. And if you don't know, fuzzers are fallible. It might not generate an input that causes you to violate that security property. Now, Echidna is a really good fuzzer, so chances are it will. But if you want a higher level of assurance, like if you want formal verification, then what you do is, once you have this property, you swap out the approach with something more heavyweight. In that case, for us, the next step up from Echidna is Manticore, where you've got a symbolic executor that gives you a higher level of assurance for proving the same property. So you can kind of tighten the noose on these particular issues until you've got total control of all the security properties that are viable for your system to test, as well as the most extensive testing method to test them. So this kind of very quickly converted the OX project from somebody that had previously done the very manual approach of, let's just get a whole bunch of testers to test the system and report me a list of bugs and I'll play whack-a-mole, to on the path to being formally verified. So yeah, lessons learned. That kind of piecemeal approach of let's just get a bunch of people to kick at this thing real hard doesn't eliminate surprise. You need to have some ability to plan forward, and to do that, you have to do some modeling, you have to do some architecture review, you have to understand where the hotspots in your code base are. And once you do, the most effective way to fill in those gaps is to use a process that provides you provable assurances out the other end, which is defining security properties and testing them. And you can do that with the approach described in the Building Secure Contracts repository that we published. Good?
Yes.
Okay, that's OX. All right, breather. So now we've got someone totally different. Paxos, why don't you introduce them, Stefan?
Yep. So Paxos is an interesting project for us as well. Obviously stablecoin, very, very similar space to other stablecoins that folks are very well aware of. What became interesting, or more subtly interesting for us, was that they came to us and asked if we had any experience with highly regulated environments. And both Dan and I come from ironically, we come from the same department at the same federal agency, but we're both very familiar with highly regulated environments, and understanding the sorts of policy and procedure needs that organizations may have. And so when Paxos asked us, hey, can you do regulated products in the blockchain space, it was something exciting for us to really get into. So you want to go on?
Perverse.
Dan? Yes.
Oh wow, regulations. Yeah.
So it was interesting because they came to us and we have an ERC20, we have some tokens here. Does it do what we think it does? But on the other side, we also operate in New York, and New York, somewhat uniquely now, but very uniquely at the time, actually has two standards that they request that you adhere to. There's a BIT license, which is NYCRR 200, and a cybersecurity reporting guidelines and requirements, which is NYCRR 500. So it was interesting for us to say, yep, we'll sit down and we'll go through these two documents and make sure that you have policies and procedures that answer both of those.
Yeah, so I think the way that this really differs from other engagements is when they ask us hey, we've got an ERC20 token, or something that uses this standard, we've modified it a little bit. Is it safe? The question is, what does safe mean to this client? Because it doesn't just mean in this case that you're looking for some issue that you could exploit on chain that lets you steal all the tokens. Like, yes, that's part of it, but there's a higher level to what safe means. And it's like safe with respect to these regulatory standards or some other potential impact that we're currently unaware of. So you have a need to think a little bit higher level about the nature of safety, given the modifications that were made. It's not just whether I can like fuzz out a bug, but you have to actually think through like, what does it mean for the token to act this way or to have this feature? Okay, so approach is pretty straightforward, similar to Compound, right? Anything you want to say here?
No, it was really very, very similar to Compound. Look at the code, and then actually sit down with stakeholders and say, what were you thinking when you designed this? What sorts of like regulatory risk, reputational risk, financial risk are you willing to take on? And what is your procedures off chain? I think what was interesting about Paxos was that they didn't ask us to review the off-chain components like Compound did, but they did include those policies and procedures within the sorts of like threat modeling activities that we did. So it was a little bit more traditional, like order books and those sorts of things. And that's where it became interesting. So.
Right. Now, we didn't necessarily use this exact technique for Paxos, but it is one that we commonly use for similar engagements. We like to use this thing called a rapid risk assessment. Stefan can walk you through a little bit about how this works, but if you'd like to see an example of what it looks like kind of in practice, we have some raw notes of us doing rapid risk assessments against Kubernetes. And Stefan can also talk through about why the Kubernetes one was especially fun. But tell us what a rapid risk assessment is, Stefan.
Yeah, so a rapid risk assessment is a process that Mozilla had come up with for their own internal systems. And it's a way to understand a component very quickly, understand what sorts of data it accesses, what sort of data categorization, these sorts of, the sorts of data that this operates on, and really come up with a very simple set of risks for a component, and then include those within a catalog for your organization. So it's not a full threat model, but it's a way to have threat modeling and have those sorts of like discovery sessions for threat modeling with a very simple, straightforward process that should take 30 to 60 minutes and should be relatively focused on a set of things. When you look at traditional like threat modeling and risk assessments, they can be long and laborious processes. So Mozilla really distilled down something that basically anyone can follow that should take 30 to 60 minutes to come up with some risks or some concerns that you have within a specific component of your organization. So we use them, like Dan said, we use them very frequently for clients that they don't necessarily want a full threat model. They don't necessarily need a full threat model, but they really want to understand what sort of risks this component itself specifically has. So they're really great. And you can see my raw notes from the Kubernetes designers, like Dan said.
I think it's a lot like the OX project, where people say they want to do formal verification, but formal verification seems like an impossible goal, that there's no way that you could possibly get there, that it's so complex and it requires teams of PhDs and you don't know exactly where to start. And just like OX, where we just sit down and say, okay, well, the most important thing you need to do formal verification is a list of properties. So let's talk to you and let's find out that list of properties. That's the first step. And if you have 5 of them, amazing, right? You're on your way. Rapid risk assessments are the same thing. Like, a lot of people look at threat modeling as an impossible task. Like, I have to go out and buy a book and study it, and I need somebody who's done it before. You end up finding all this junk from like Adam Shostak and all these old crusty Microsoft books about how they deployed it in like Windows XP SP2. But this is equivalent to what the like verification process that we led OX down is, except for threat modeling. It's the minimum viable threat model that you can create, the first step that you can take down that path. And it fits really well into consulting engagements because we have a limited time too. We might only work with a client for 2 weeks, 3 weeks, and we're not going to gain a complete and total understanding of everything and every risk. But this will very easily kind of bubble up the most important ones. And that's progress, right? You want progress. You don't need like a perfect solution. You just need forward motion. Okay, so what did we find?
Well,
Tell us, Stefan.
The interesting thing with Paxos was that they had this law enforcement role. One of the regulations for New York State is that you have to have a little bit more visibility into any financial system that you're designing. And so Paxos made a slightly modified ERC-20 and the various accoutrements of that sort of systems, just adding this law enforcement role. And the interesting thing is, by trying to adhere to this regulation, to NYCRR 500, they actually introduced some issues or some concerns that we had within the application. So for example, we saw this law enforcement role. We looked at how the contract was default deployed, and they didn't actually set this role at first because Paxos may not actually understand or know where this account will be, right? New York State DFS didn't necessarily have a key that they wanted to use offhand that they could give to Paxos. There wasn't really that defined process. But Paxos is trying to adhere to this standard, so they define the role. However, in setting that role, or in saying that someone is now the law enforcement address, they're alerting everyone within the Paxos system that, hey, player 3 has entered the game, right?
Cops are here. Everybody run. Hide your beer.
Right. And so one of the things we wanted to talk through with them was that we don't necessarily consider this a huge risk, right? You're not destroying the security of the system by doing this, but you now are suddenly alerting anyone who has untoward or shady business within the Paxos system that, hey, law enforcement is now looking at us. And there were some other interesting interactions with the law enforcement role with regard to burning and minting that we saw as well that wouldn't exist in a system that didn't implement this regulatory policy that they were trying to adhere to. And on the flip side, when we were reading through NYCRR 500, they have very stringent requirements for logging. And you have to tell your superintendent, which is basically a person within New York State DFS, if anything had occurred. And so we went through and found locations that Paxos couldn't necessarily tell if something had occurred. And in that lack of visibility, it wouldn't necessarily normally be a security concern for us, but now they couldn't actually alert New York State DFS that something had occurred. And so they had to.
So your regulator shows up at the door and says, hey, give me this data. And you look at the code base, you're like, I didn't collect that data. And then they fine you.
Right.
That's a bad thing. You don't want that to happen.
Right.
And that gets back to the question before of like, okay, so they made this law enforcement role. That's the modification they made to some standard ERC-20 code base. There wasn't an implementation flaw there. Like they didn't, mess up some integer handling that let people do an integer overflow. That wasn't the issue, but the safety issue came out from understanding like, okay, well, what is it going to look like when we use this? And what are the potential impacts to Paxos or to our clients or to our users that might result? So that kind of risk conversation had to happen for this to become known as a potential issue. Yeah, okay, great. So lessons learned. Stefan, follow us through here.
Yeah, I think, unfortunately, as much as we in blockchain spaces maybe want to get away from some of the traditional finance issues or the traditional, like the heavyweight, nature of traditional finance, some of those things still impact us, and some of those things still, are still useful for us. So you do have to pay attention to these sorts of things. If you're operating in New York, you have to adhere to New York standards. Other states are moving online with this as well. But, they not only give you some guidance, NYCRR 500 is actually a pretty good, like you must be this tall to ride sort of thing for any firm. But they also can have implications for how you're coding things and potentially, as we saw with Paxos, introduce some other areas that are security concerns that we would have, across the code base that you're implementing itself. So it was a fascinating project itself.
Yeah, it is a recommended exercise to go look at that NYCRR 500 regulation and just see if you meet it, even if you don't operate in New York. Because yeah, like Stefan said, that is the basics. And it's wherever you do operate, same thing is going to show up there soon if it hasn't already. Okay, our last case study, Tendermint. So hopefully everybody here knows Tendermint. I don't have to define who they are for you. Let's just skip that. So Stefan, like they had a lot of problems from all over the place. I mean, they're a pretty wide-ranging big company, and there were some on-chain things that they had looked at. They felt pretty comfortable with, and they asked us about different stuff. What did they ask us about?
Yeah, so they were less concerned about the sort of like how does our staking and slashing work, for on-chain components, and they were much more concerned about, does the code that we wrote in Go actually implement that? Are we accidentally exposing keys? Is there something that breaks our consensus mechanism horribly? And then later, as we did the interblockchain spec, they were really just concerned, does our spec actually make sense? Does it specify what we think it's specifying? And then also, does our code actually match that spec? And this is a question that clients come to us quite frequently with. We wrote this great design document and all these guidance and policies around them, and then we wrote code, but how do we know that the code actually does what we wrote into this document? And so we very frequently are tasked with reading over a document, coming up with properties, coming up with things that we'd like to test, and then finding interesting ways to test them with the client, either with their own code base or with code that we write. So Tendermint was a great example of this that sort of trifecta of things, of traditional InfoSec, where do we store our keys and whatnot, consensus issues, and then specification issues themselves as well.
This is perversely where you're actually lucky writing code in Solidity, because as bad as the language design is, at least you've got programmatic tools that let you prove a spec. So you've got things like Slither, you've got things like Echidna, you've got things like Manticore. But if you're writing a bunch of Go and you have this you wrote your spec or you wrote your security properties and I use the word spec, security properties, and invariant basically interchangeably. They all essentially mean the same thing. But if you're writing your spec in English and it isn't consumable by a tool, or maybe a tool doesn't exist, then what you're doing is trying to prove that spec in your head, and that's kind of fallible. So in a best case scenario, you have a tool that proves it. In a slightly less than best case scenario, you hire Trail of Bits to build one. And then in the worst case scenario, which is, maybe not the worst case in the world, you hire one of our, human computers. We lock somebody in a closet and let them do a man behind the curtain to prove your spec for you. And I think that's more the situation that we were in here. We learned a lot about Go along this process as well, which we'll talk about. But okay, so our approach.
So I don't know if everyone has actually seen Go or really seen the ecosystem for Go, but like Dan mentioned, the ecosystem for Go is at best considered nascent when it comes to security tools. It's gotten a lot better since we worked on Tendermint. We've also given back some of the tooling that we have, but static analysis just wasn't really there. So there was a lot of us hunting through the code base, finding things that looked interesting, and then using property testers like Gopter and GoFuzz to actually see how far into the code base we could get to actually break things. So like Dan mentioned, it's one of the few times that you're luckier to be writing in Solidity than you are to be writing in another language, because the tooling just wasn't there for Golang itself at the time. And then we also did a network review. So Tendermint includes several different types of networking. There's several different areas that you can interact with Tendermint nodes, both for statistics as well as for actual network interaction. And so we mapped those out just with like Nmap and traditional InfoSec tools, and then started to interact with them based on what we knew about blockchains, what we knew about Tendermint itself, and then what we also knew about, the usual like web standards and those sorts of things. And then for the spec, we started to actually look through, identify a bunch of claims, identify areas that we felt would be really poignant to find, and then brought those out and lifted them into code so that we could actually start to check invariants and check things within the IBC code base itself. So it was an interesting system because of the sorts of things that we're doing and the languages that we were working with.
Great. So clearly we found some issues, and a lot of them were with Go, but a lot of them weren't. So try and describe that end result to us, Stefan.
Sure. So I think this was the first time that we started to see Go has a lot of helper functions for file systems, but the documentation for those is actually a little diffuse as to what the problems are. And there are certain assumptions that Go itself bakes into its standard library with regard to file systems that we've seen as a failure mode time and time again. So a great example of this is os.makedir all. So if you want to create an entire tree, you run this function and it does the thing. However, it doesn't actually check if the directory tree already exists. And if an attacker has preceded the file system, they now have access to private keys or other information within your system. So this was one of the places that we first saw the real file system issues within Go itself start to stand out. And then we also had all the traditional areas that we've seen. Understanding the edges of your application, like where are environment variables exposed, where are environment variables used, are we validating those sorts of things, are we using channel security, and even simple things like web standards. Are we following CORS, the cross-origin resource sharing standard for web APIs? Does a web API exist that shouldn't be unauthenticated and is exposed to the entire network? Those sorts of things. So it was a lot of the like, oh, we have a blockchain, but now we have to bring all of our traditional knowledge and look at these things through the lens of blockchain itself. So a lot of interesting results and a lot of like cutting our teeth on these sorts of things as we were exploring them in a blockchain specific context.
And the note about the file formats at the bottom. I mean, generally when a system is consuming a file format, it's usually some kind of unstructured data that's coming from a user or coming from outside the system, or else it would have been like JSON, right? So usually when you go through one of these risk assessments or you have a conversation with a developer and somebody says file format, or, I'm consuming a file to me or Stefan, then our, little spidey sense or whatever starts to tingle. And we realize that, okay, this is probably going to be one of the biggest risk areas of the system. And one of the ways that you can limit it is you can fuzz the heck out of the system, or we can find some way to isolate it, whether it's through sandboxing or some other containment mechanism. So, that's one thing to know, that like beyond the standard set of like, hey, is all the network data I have encrypted, or am I actually following the kind of like web security standards that I need to? When you're dealing with files, be super careful. And clients of ours have hired us to either write like libfuzzer drivers, LLVM libfuzzer, AFL drivers, or to actually implement some kind of sandboxing that limits the impact of successful exploitation. Anything there?
Yeah, I was going to say, to add to Dan's point, for the love of all that's good, if you can avoid implementing a file format yourself, please do. There's lots of edge cases that you or I or
you are not prepared.
Right. And it's a surprisingly non-trivial thing, right? It's just a file. I'm going to read in the file, parse it, and do the thing. But there's lots of edge cases, and it's surprisingly difficult. We actually found not one but 3 different edge cases with files in Tendermint itself. We found them with some JSON formats. We found them with their protobuf implementation called Amino, and then we also found them in the low-level write-ahead log for the consensus database itself. So yeah, there's a lot. Yeah, Evan has a great talk on this.
Yeah, if you really want, if you're not taking our word for it that like file systems are about as complicated to implement as like a cryptographic system, then you can listen to this talk. It's from Evan Sultanic, and it's based on a DARPA program. So this is a DARPA hard program where they think they need $40 million and 4 years worth of the best talent in the world to work on. because parsing files is just that hard. So this is an amazingly entertaining talk that I would recommend listening to if you have the free time. But moving on. Oh, we already basically talked about all this stuff.
Yeah, absolutely.
Yeah. So, right. Yeah. Do go safely. Okay, cool. Yeah. Don't get confused about types, validate states, and actually use the Go cryptography language, Go cryptography library. It's pretty good. Don't roll your own crypto. Okay, so we've reached the end. A few concluding thoughts we wanted to share with you. Stefan, why don't you take most of these?
So I think, as we've started to work with NYCRR 500 with other organizations besides Compound and besides Paxos, I think if you're going to look at something, or if you're looking for like, how do we come up with security guidance or IT guidance for ourselves, I think NYCRR 500 is probably a good checklist. It's unlike other standards. It's not hundreds of pages. It's like 30 pages. It's very short. It's written in, it's not written in legalese. It's not written in like NIST documentation. It's fairly straightforward, and it has simple things like make sure everything has multi-factor authentication, make sure these people know who to give alerts to, that sort of thing. It's really a very good guide, a high watermark for where you should be as an organization, even if you're not trying to do work in New York State or work with DFS style regulations. And also too, traditional security itself, even as blockchain companies, even as we move things off of like bespoke banking applications or bespoke wire formats or those sorts of things, traditional security itself still impacts you. No matter where you're moving towards or what you're looking to do, you're still going to have keys, you're still going to have computers, you're still going to have people in the loop. And trying to look at what we've learned in the past and apply them to your organization will help you a ton. And then also, obviously, including things like formal modeling and assessments, those are extremely helpful. But looking at things holistically, from design, from formal models, from reaching into the code base and pulling out a bunch of bugs, all of those things will help you there. And another section or another area of guidance that we've run into with many clients is actually understanding business risk and system risk. So a smart contract might be a system within your business, but understanding what sort of reputational, regulatory, and financial impact that smart contract can have towards your business is extremely helpful. And then obviously going through, like we mentioned earlier, and doing things like rapid risk assessments, like formal modeling, understanding the properties of a given system. These will all help you actually improve your security across your organization, even as you improve things piecemeal across the various components. And then lastly, on-chain security is not solved either. I don't know, Dan, you want to go through that?
I mean, the point here is you can't just manually test a piece of software 1,000 times until it's secure. You need to follow a deliberate process to get yourself there, and it needs to provide assurances out the other end that you're doing things correctly. And the way to do that is the process that we described for OX. It's also described in this Building Secure Contracts training material. But that's where we see most people still failing on the on-chain part, is they're not looking at it holistically. They're just banging real hard. And they think that they're spending a lot of money and they're hiring a lot of smart people, and therefore the code base is probably going to be safe now, but it just leads to surprises later. So really, like when you are making security investments into your on-chain components, they need to be providing the outputs that you really want. And the way to ensure that is that process. So like, don't approach testing haphazardly. It's not just like hire some random guy and then hire some different guy the next week and hire some different guy the next week. That actually ends up with poor results, because a lot of the challenge of following that process of building a list of security properties and then testing them is you need to know what the code actually does. So if, for instance, if you've got a budget of, I don't know, let's just say 100K to do security assessments of your on-chain stuff, and you take that and split it 4 different ways to 4 different people, and each person's got 25K, then everyone's going to have a superficial understanding at the end of the project. Whereas instead, if you give it all to one person, that one person can actually use the greater time that they have to learn what's supposed to happen on the blockchain and actually write out those security properties and actually write out the tests for them. So in my opinion, it's actively harmful to do this approach that most people in the blockchain community follow, where they just try to hire everybody under the sun and let them take a crack at their code. That's my manifesto. So we've reached the end. I'm really happy to open it up for questions. Stefan and I have some time to stick around, and I'd love to help anybody with whatever they're dealing with. Not whatever you're dealing with, because there is a lot of COVID stuff out there that I just am not going to be useful for. But any security stuff, please ask.
Dan, Stefan, thanks for that presentation. It was fantastic, and hopefully eye-opening for a lot of folks on the call. Yeah, let's open up for questions. Folks on the call, you are on mute by default, so if you want to ask a question, just unmute and ask your question, and then please mute yourself again afterwards. I'll start with kind of a quick question. Dan, when do you think is the right time for a company to engage with Trail of Bits? Is there a certain milestone? Is it right before they launch their test net? Is it just generally as early as possible? Or is it, when they start hiring their first, security engineer?
Yeah, great question. So just like the conversation around formal verification and rapid risk assessments, where people build up these amazing pictures in their head of what a threat model looks like or what formal verification looks like, there are usually smaller steps that you can take much earlier in the process that end up getting you there much easier. Same thing goes for security reviews. A lot of people do approach us right before they're about to ship, 1 month before they're about to ship, 1 week before they're about to ship. They dump a whole bunch of code on our head, and then we try our best to whip them into shape. But it definitely works out better when people approach us earlier. We don't have to do giant monolithic security assessments like some of the ones that we discussed here. A lot of times we can do a 2-day kind of course correction. We can look at some practices that you've adopted and bop you over the head and say, stop doing that. It's going to hurt you later. Or we can do some of these architecture reviews of a spec on paper. If that's all you've got, we can tell you that, hey, it says here that you're going to write your own file format. Don't do that. Let's try and find a comparable alternative that we can swap in instead. So you have to write less code, you can ship faster, and you don't have as many security issues. So we can always kind of manipulate and change the way that we offer services to fit the level of maturity that you have of your product. Whether it's a 2-day assessment, a 1-week, architecture review, or a 4-week giant detailed security review, doesn't matter to us. We're happy to fit in wherever we can.
Gotcha. And I guess a quick follow-up to that, for the 4 case studies that you went through, how much time did each one take? Not just start to finish, but from a CEO's perspective, who needs to figure out, how much of their engineers' time they need to make sure they clear out to work with you guys.
Oh.
How would you kind of estimate that?
So, well, let me give you a kind of my memory of the level of effort for all these things. So I think Compound this was an extensive engagement. This was like 12 person weeks. We measure projects in person weeks, and we assign engineers in pairs. So that meant this was a 6-week project. And we reviewed both their on-chain and off-chain systems, as well as a bunch of policies. So there was a lot going on, right? So this Compound assessment was big. OX was 10 person weeks, where there was 2 to do the architecture, and then there was 8 to do the security property development and testing. So that was also a fairly sizable project. Paxos was short. Paxos was, I believe, 4 person weeks. So in that, they had a much simpler system, right? Like they're not OX, they're not a DeFi application, they're a stablecoin. So the level of complexity that was being reviewed was much lower, which meant that we could make a lot more impact on their system by investing less effort. And that's, again, like a question of how am I going to design my system? Am I going to design my system to be complex or simple? If it's complex, it's going to require just as much effort, like that much more effort to review. If it's simple, then maybe I can get by with, you know, a lot less security investment and get the same output. And then Tendermint was 8-person weeks.
Yeah, it was something right around there.
Yeah, it was about a 4-week project. And that, you know, again, was super complicated. Like we had to look at consensus bugs, specification bugs. We looked at some off-chain stuff. So a lot going on. And it was a very broad kind of review of a lot of systems. So now to bring this back of like, okay, that's about how long these engagements took. What does it look like day to day while you work with us? If we're doing an architecture review, you might want to assign a point of contact and make sure they have at least like an hour or two a day to communicate with us, because we're going to have a lot of questions. You know, you can't answer what are you trying to build unless a developer tells you, because a lot of times that's not specified in the document already. You don't have documentation for that. You've never actually thought about why you built it. You just built it. So those conversations need to happen. And in order to do that, you need to have the time for it. For instance, on Kubernetes or on another project that we just finished, I'll show you, we did a blockchain voting system just recently. Votes. In votes was massively complex, and we had to, we had 8 meetings over the course of, 4 weeks. We redacted all the contents of those meetings, but each of them was about 60 to 90 minutes. So it really depends. Like if what you're trying to get at is this more holistic understanding, then it's going to be a two-way street. On the other hand, if you want to do a security review, if you're looking for implementation bugs in a system you're about to ship, or if we already have that understanding from working with you previously, then the impact on your team is pretty light. Usually we just set up a shared Slack channel. We'll ask you on average 1 question in a day. So you can continue to go on your business. You can continue to even work on the product while we're reviewing it, as long as you're making pull requests and not committing directly to master. Then we're going to be just fine. Like we've seen a dozen, a million, whatever Go code bases or Solidity code bases or Rust code bases before, so we can kind of handle ourselves there. But yeah, it really depends on what you want.
Got it. That's super helpful. Thanks.
Mm-hmm. And this is a fun, if you want to, see a fun report or whatever, kind of just make yourself feel better. You could read this report and you'll know that you'll never be this bad. In case you're feeling down about your own state of security practices. I know somebody's got a question in the audience.
Hey, this is Harry from Off-Chain Labs. I have a small question, which is just, so you mentioned, of course, that, Solidity at this point, you guys have pretty solid tooling for doing static analysis. Go, at least at the point when you were doing Tendermint, did not have great tooling. How, in terms of kind of the client-side compiled languages, what has kind of better or worse static analysis tooling out there?
Are you talking about like React and TypeScript and that sort of stuff?
No, so like, Rust, C++, Go.
So,
oh, sure. Yeah, Stefan, go ahead.
Yeah, so it's funny that you asked that, Harry. So I think the interesting part of Go now is that they've because Go is so easy to analyze, you can just import the AST library and add an analyzer yourself. There's honestly a plethora of little static analysis tools that report in different formats, that give you different types of bugs, that may or may not have different edge cases. So there's something that we actually have a blog about where inf-assign, to find ineffectual assignments, catches one error that you would expect error check to catch, but Urcheck actually catches one ineffectual assign based on flags. And so you have to know how to run both of these tools. However, Go has gotten really good if you know which tools to run and if you know which things to use. Go has gotten much better with static analysis, even if the market is a little bit of a milieu. However, as I'm sure you've seen, if you have to determine if your Go dependencies are out of date, run Sneak and maybe pray. Otherwise, it's very difficult to do dependency management in Go. Whereas Rust, there's not as many security tools that'll say, hey, here's a bug, here's something that looks a little off, because the compiler is so strong. But Cargo Audit is super easy to use. You can install it from Brew, and there's lots of tooling there to help fuzz things like Cargo Fuzz. So it's interesting to see where the two languages fail. Obviously, C and C++ have the most guidance, the most tooling, the most different things that you can do, everything from rats all the way up to NASA's ICOS. There's a lot of different, there's a whole compendium of power that you can follow there, or a continuum of power that you can follow. But obviously, those are very painful languages to work in yourself. So it's certainly interesting to see the sorts of things that we have. And yeah, Dan brought up one of the blog posts that Bobby wrote about this. And we've given a number of talks on this as well.
Yeah, we did a full review of the whole Go ecosystem, of the maturity of various tools for doing static analysis, for doing dynamic analysis, fuzzing, property testing, the whole gamut. And this is just, a core mission of the company is just share as much knowledge as we can. It's not just blockchain security that we end up publishing. There's really a wealth of information that's kind of hidden inside of our blog. But this is one of the more common kind of assessments that we've been doing lately. A lot of our client base has been shifting to Go. So it made sense to accumulate all this knowledge in one location. And then part of our follow through too is, like Stefan said, the static analysis tools themselves aren't that great. So we're taking it upon ourselves to fix that. We have a custom fork of GoSec that we've been trying to remediate some of the issues that we had with it. And then we also have this private tool that might become public later that includes some of what we would do if we designed it from scratch. So we go through that process for every major language or every major ecosystem that we see our clients start shifting to. And I think Rust is probably going to be the next one in the next 6-month cycle for Trilobits.
Awesome. That was super helpful. Thank you.
Cool. Yeah, definitely read this blog post. Sounds like you might be using Go. Yeah.
We also gave I gave a talk at OWASP Global DC on what we saw specifically in the Kubernetes in the Kubernetes assessment, with regard to Go. There's that. No, not symbolically executing, of swimming with the cube cuttlefish. I don't know if it's on our. There you go. Yeah. That one. This talk actually goes through what we saw in Go in the Kubernetes code base and the sorts of foot guns that Go itself has that you can run into.
Well, how else can we help you all?
Hey guys, Mo here from BitAccess with a quick question. Maybe just from more of an operational security perspective, for small companies that are growing, it can be challenging to make sure that you maintain the same operational security when you have more people than when you have less people. Can you think of just other than reading the Trail of Bits blog, where should we be constantly keeping up to date with best practices as well as, talks or books? Are there information sources that you recommend that people should be watching or reading constantly?
I'll introduce what I think the answer might be, and then Stefan, you can follow me up. So I'll just say that a key benefit that you get by working with a security firm like ours is prioritization. Because you're right, there's this overwhelming amount of information that comes out all the time, where the media, trade publications, Twitter, whatever, everyone's trying to sell you on the latest and greatest threat. And a lot of times the latest and greatest threat doesn't actually matter for anything. Yeah. And it's confusing because people are just throwing this stuff at you and they're saying it's a massive risk. And it's the person discovering it saying so. So as a non-expert, you don't really have the ability to grade the quality of that information and really figure out prioritization of like where that should sit. Is this something I need to pay attention to now or a year from now? From my perspective, at least like one way to like help avoid those problems is to make good decisions early about the languages, frameworks, and other kinds of tools that you adopt early, because you can choose to write your entire code base in C++, or you can choose to write your entire code base with Rails, or you can choose to process credit cards yourself. But if you do that, you might be inheriting a lot of risk and require a lot more maintenance of that down the line that as a small company, you're just not prepared to handle. So for small companies, we usually advise transferring as much risk as possible to third parties. Like you should try to build as little systems as you can and try to allow people much larger than you to solve security problems that you're not prepared to solve. So that's the high level answer. And then maybe Stefan can give a little more detailed one.
Yeah, no, I think that's spot on, Dan. I liken a lot of the security concerns that we run into with clients to choosing an algorithm or choosing a language, like Dan said. A lot of the security best practices you could read in books stretching back from the late 60s and early 70s. Like, hey, make sure that not one person can have access to a very sensitive function. And that sounds obvious in retrospect, right? When a blockchain company had a CEO walk out with all 25 million funds and fake his death or whatever it was. Later you go back and you're like, well, obviously he shouldn't have had sole access to things. But those sorts of like basics or those sorts of best practices are fairly standard and fairly well known that you can come up with. I would say, some of the worst vulnerabilities I've had are just asking people for stuff, like calling up a company and saying, "Hey, I'm Stefan. I'm actually I work in your satellite office, and I was wondering if you could give me access to something. I'm sorry, it's my first day, and I get access to whatever I wasn't supposed to have access to." And so, like Dan said, you're constantly bombarded with, Twitter, there's some new vulnerability or there's some new hijack or there's something you should be concerned about. And really, most organizations are hacked by very old, very simple problems. Yeah.
Yeah.
So,
I mean, the kind of follow up there is like, okay, so that CEO shouldn't be the sole person that had the keys, or there should be, basically the class of like credential management, right? Like that is an issue that people have trouble solving. So as a small company, what do? Well, you have a choice. Do you start using 1Password on day 0 of your company, or do you try to shove it in, retrofit it in, 2 years later? And that's kind of one of the things that we think leads to good outcomes. Like another way is like Trail of Bits. So right now we're all working remote, right? But Trail of Bits has always been remote. I've always had half the company working remote. So finally adopting a full remote setup wasn't that hard for me. I didn't have to make a big shift. Same thing goes for all these security process and like security techniques that you might want to do later. So trying to be like diligent about adopting those fundamentals early and having like a low effort way to start on the process and get on that treadmill and like try to solve them early in your history is going to be a lot less pain later.
we do have a list of books and articles though on the basics. So similar to like, how do I get started with algorithms? How do I get started with languages? We do have some foundational books on like incident response, on security best practices, on those sorts of things that we can also send over afterwards as well.
Yeah.
Yeah, that'd be great. Thanks a lot, guys.
Of course.
Cool. Yeah, sorry, there's no magic bullet there. Yeah. It's kind of just like eat your vegetables and
and I mean,
try to avoid McDonald's for a few years.
I wasn't expecting. It's just like, you can have like regular meetings where you're trying to keep your team up to date about security practices. It's just sometimes it's, I actually find it kind of hard sometimes to get content for those meetings, for those like regular security meetings. And so I just like to know where I can constantly be going or things like that to keep them fresh.
So if you're looking for those things, a really great resource is NIST NVD database, the National Vulnerability Database. And if you, and there's no information sharing and analysis center for blockchain, although that could be interesting. NIST at least gives you a threat feed of the latest vulnerabilities of things that are out there. So there are several. There's a FS-ISAC, the Financial Services ISAC, for things. You can look at that. Risky Business is a podcast that Dan and I have both been on.
Yeah, I'll argue with Stefan here. I think don't read NVD.
Yeah, no, it's fine.
There's some stuff that's buried in there, but I think it still requires some expertise to dig out the good stuff.
Yeah.
Really, if you want somebody else to analyze this stuff for you, the place that you want to go is Risky Business. These guys are just a weekly podcast, and they also started publishing some articles. Like, for instance, they had a really great roundup just recently. Where is it? Yeah, here we go. How companies are adopting remote access and remote working with the whole COVID-19 stuff. And this article is based on a live conversation that they all had with the former chief security officer of Facebook, Alex Stamos, and I don't know who this guy is, but was that Adam Bailo? Oh my God, I've never actually seen him. He's basically me, but works for a different company. What's their company name? I forget. Anyway, he's from New Zealand, and they don't do blockchain stuff. They just do like traditional kind of network pen tests and remote red teaming things. But he's got a good head on his shoulders. So this is really, I think, some of the best content that you could use to engage the rest of your company, because it's already been formulated in that way that it's a still technical news piece that you can just take and represent without thinking too much, to make people realize, like, oh, wow, this is actually kind of interesting. The security guy has something neat to say today. And sometimes the content is useful, like this remote access stuff.
Awesome. Thanks a lot, guys.
I also think, and where I was going with NBD, but you can get this through GitHub. To be honest, a huge amount of vulnerabilities come from people just using the wrong dependencies. And having GitHub, like using GitHub or using something in your CI/CD pipeline that's just like, hey, this dependency is broken. That's really the best sort of thing that you can do. And like you said, it's very difficult to come up with like a security briefing every week and talk to people about like, hey, this is stuff we should be doing. But it's also very difficult for developers to just keep up with security saying no, or security saying this is broken. Whereas if you make things like chat apps, you make things like hook into GitHub, you give them visibility into things, suddenly it's less like the security people are being jerks again and saying no. And suddenly it's like oh, hey, something failed on CI/CD, I got to fix it. It's super simple, super lightweight. And honestly, it fixes a lot of the things so that when you do come to a firm like Trail of Bits, you're not spending a lot of money for us to say, there are 53 low-hanging fruits because you didn't update your system in the last 5 years. And if you had, we would look at other things. Whereas then we can focus in and say, actually, there's one really high vulnerability edge case here that was difficult to find, and you paid us to do this because we know this, and we can bring in exotic tools and help you with these sorts of things. And you're really getting your bang for your buck because you're using us and you're using firms like us as the actual security subject matter experts, rather than doing the sorts of like security janitorial work of like dependencies and whatnot that you could do on your own. Does that make sense?
Yeah, I just call this out because Dependabot's amazing. I love Dependabot.
Yeah.
But Dependabot only really works on a small number of languages right now. You can opt into their beta that gets it to work on a wider variety of systems and make more complex patches, which is something I'd recommend doing because we've had a really good experience with Dependabot. Okay, I think we've beaten that question to death. What else? I do think technically we're out of time, but
Yep.
If other folks want to contact us, we got our like sales form on the website, right? So you can obviously just get me through here, but through most of our GitHub repos, for instance, this one. Oh no, that's not a good one. Let's try. Through most of our GitHub repos, we have a little Slack badge. And if you click this, you can join our Slack. And inside of our Slack, we have a channel, multiple channels, set up for blockchain security. And where's the Critic one? And Critic, our continuous assurance system that's integrated with GitHub to help people not write bad Solidity. So you can follow up with us through a variety of different ways. You know, join our Slack, hit me up on email. I'm just dan@trailofbits.com, or you could join our Slack and poke people in my company directly. Whatever floats your boat. But we're happy to help everybody we can.
Thanks, Dan, and thanks to you and Stefan for another great presentation. I'll also send a follow-up email afterwards with your guys' contact info if anybody wants to reach out or has any further questions. But you know, super appreciate you guys taking the time. I think it was really educational for everyone, and it was really well done.
Thanks. Okay, happy to be here. Thanks for the invite.
Thank you very much, everyone.